Good morning, everyone. Today we are going to discuss about cyclone and anticyclone. Okay, two opposite air pressure conditioning Earth's atmospheric phenomena. First of all, the Earth atmosphere is in a constant motion driven by a simple, powerful force. Okay, the difference in air pressure, that is low pressure and high pressure. This imbalance creates two dominant opposing systems that shape our climate and daily weather. That is cyclone and anticyclone. Okay, low pressure system cyclone centers of rising unstable air, and high pressure system anticyclone centers of sinking stable air. Cyclone. A cyclone is a large scale low pressure system where air converges. Okay, air converges at the surface and ascends. This upward movement is the key to its character. Okay, associated matter weather. It is the architect of unsettled weather responsible for widespread cloud formation, significant precipitation, rain and snow, and general atmospheric instability. Okay, always remember that cyclone is caused by due to low pressure, low atmospheric pressure. Okay, low atmospheric pressure. Okay, the cyclone signature moves inward, upward, and spinning. Pressure system characterized by a central low pressure system. Okay, central low pressure. And governing forces, pressure gradient force, air flows from high to low pressure, air flows from high to low pressure. Then Coriolis force or Earth's rotation deflects the path of the wind. Okay, friction shows wind at the surface, and its direction horizontally winds move inward towards the low pressure center, and vertically the air then moves upward. Okay, cyclone moves in the northern hemisphere counterclockwise, that is anti-clockwise, and clockwise in the southern hemisphere. Anatomy of the updraft, the cyclone's vertical structure. This is surface convergence, low pressure. There is a high pressure zone. Also in this side, there's a high pressure zone, and this is the convergent movement like this from high pressure to low pressure, and upward direction. Okay, surface convergence is step 1. Surface convergence. This is the surface convergence process. Then forced ascent, rising air. This is the forced ascent, rising air. Then adiabatic expansion, air cools, its rise and expands. Okay, adiabatic expansion, air cools and make the cloud. Then condensation, that means cloud formation. Then upper level divergence aloft maintains the system. Okay, upper level divergence. Okay, this is the key process of cyclone. Okay, outcome, this entire process leads to condensation, cloud development, and precipitation. There are many forms of cyclones, basically 3 types of cyclones predominantly available in the Earth atmosphere: tropical cyclones, extratropical or mid-latitude cyclones, and polar cyclones. Okay, tropical cyclones, formation over warm air ocean water, less than temperature less than 26.5 degrees Celsius, and symmetrical featuring an eye well, and rain bands. An example, Bay of Bengal and Arabian Sea systems. Then extratropical or mild latitude cyclones, formation in mild latitudes where cold and warm air masses meet, and structure asymmetrical, defined by fronts, warm and cold front. Okay, next, polar cyclones, formation over high latitude Mediterranean regions, structure weaker, cold core systems. Okay, these are 3 basic types of cyclone: tropical cyclone in a tropical region, extratropical in mild latitude regions, and polar cyclones in global North Pole and South Pole of the globe. Okay, secondly, the anticyclone. Okay, anticyclone is the opposite of cyclone. It's gets from a high pressure air system. An anticyclone is a large scale high pressure system where air descends from above and diverges at the surface. This downward movement defines its character. Okay, associated weather. It is the architect of calm, settled weather, producing clear skies, dry conditions, and strong atmospheric stability. Then the anticyclone signature moves are outward, downward, and spinning. Pressure systems characterized by a central high pressure system, core system, and horizontal movement, winds move upward away from the high pressure center, and vertical, air moves downward to replace the outward flowing air. In a northern hemisphere, it was moving clockwise, opposite to the cyclone, and in southern hemisphere, it moving counterclockwise, that is anti-clockwise. Okay. This is the anatomy of anticyclones, vertical structure. Okay, upper level convergence like this. This is the high pressure center, and this is the convergence portion, and descending air warms as it compresses adiabatic warming, and surface divergence. This is the surface divergence. Okay, this is the anticyclone. Outcome: this warming and sinking motion suppresses cloud formation, resulting in clear skies and dry weather. The two origins of the anticyclones: thermal anticyclones, cold core, and dynamic anticyclone, warm core. Okay, thermal anticyclone formation caused by intense cooling of the ground, typically in winter over large land masses. An example: the powerful winter high pressure systems over Central Asia and Siberia. And then dynamic anticyclone, warm core formation caused by large scale subsidence of air in the upper atmosphere, like a large scale subsidence. An example: the semi-permanent subtropical highs, like example of host latitudes that influence global deserts. Okay, these are two types of anticyclone: thermal anticyclone and dynamic anticyclone. This is a comparison between cyclone and anticyclone. Okay, pressure, low pressure in terms of cyclone source. Okay, ignore it. Okay, and anticyclone pressure high, and air movement converging and rising, and air movement diverging and sinking, and weather unstable and rainy, and weather in anticyclone stable and clear. Okay, in terms of cloud formation, in cyclone extensive cloud formation. In terms of cloud formation, anticyclone creates minimal cloud formation. Okay, in wind direction counterclockwise in the northern hemisphere, and anticyclone in wind direction in northern hemisphere is clockwise, opposite to the cyclones. Okay, these are basic difference between cyclone and anticyclone. Again, cyclone is a low pressure zone, is a convergent and rising air movement. It creates unstable and rainy weather, and it's extensively formed the cloud, and it moves counterclockwise in the northern hemisphere. On the other hand, anticyclone is a high pressure zone, and it's a divergence and sinking air movement, and the weather condition is stable and clear in this anticyclone, and cloud formation is minimum, and wind direction in northern hemisphere is clockwise. Okay, the importance of cyclone: global thermostat, redistributes heat and moisture from the tropics to the poles. Okay, agent of hazard causes extreme events like floods, storms, surges, and landslides. An energy mover, a primary mechanism for atmospheric energy transfer. And a rule of anticyclone: weather extreme driver associated with heat waves, droughts, and intense cold waves. Air quality regulator, can cause atmospheric stagnation, trapping pollutants and leading to poor air quality. Monsoon modulator, crucial in regulating monsoon breaks in South Asia. Okay, in this class we have learned about cyclone and anticyclone, then its formation, different stages and different types, and difference between cyclone and anticyclone, and importance of cyclone and anticyclone. Okay, if you have any doubt and query, just let me know in the comment section. Thanks for watching. Thank you.